Hello, welcome to this first video. This is on function notation. We have a couple different ways to talk about a function. This is a big topic, but we're only interested in a narrow piece. You may know about this, but it's very important, so I want to make sure that we cover it. One of the things we're going to be looking at is this notation, commonly read f of x. Another notation here, which is less common in high school, is where we have our input value called the domain value. This arrow shows we're going to apply this function rule. The name of the function is f, and we have an output value. The output is called the range. So don't confuse that with the range from statistics. This is range for functions, and it just is a word for the output of a function. Finally, this guy is called date of x in this case. This is often, you see this a lot in computer programming, where you may use a whole English language word for a function rule. It's some algorithm the computer is going to follow to take an input value, and in this case, convert it into a date that a human being could read. Okay, so let's take a look here at this first table. So again, we remember like another name for input is domain, another name for output is range. I bet you've seen this kind of function machine idea before. The function has a name. In this case, it's called Crunch. It has a rule. It has steps it follows, one step at a time. So anything I dump into this machine Crunch, first thing it's going to add 4. Then it's going to take whatever I got and multiply by 2. Then it's going to take whatever I got and add 10. So I already started this over here. So if I take a value for my in, then I'm going to dump into the top. So I toss it into this machine here. So I'm going to add 4. Okay. 0 plus 4, that equals 4. So that's my first step. Okay. Then I'm going to take the result of that addition and multiply it by 2. Okay. Times 2, which gives me 8. And then I'm going to add 10. And that gives me my output, which is 18. So when I put a 0 in, I got an 18 out. Similarly, what happens if I put a 1 in? All right, so if I take a 1 and dump it into the machine, okay, well, 1 plus 4, all right, is 5. Okay, multiply that 5, the result of that, by 2. I have 10, add 10, and I'm going to get 20 as my output. Okay, so you can work out the rest of those. That's not very difficult. If you look at this notation here, it's really going to give me, it's essentially the same thing. I actually kind of like this notation in some ways, right? It just shows if I dump a 19 in here, so I put a 19 into the top of this, well, what's it going to do? It's going to crank through these steps one by one. So 19 plus 4, take that times 2, add 10. Watch out for your order of operations because we're adding 4 first, then multiplying by 2, then add 10. So be real careful about that. It's not going to work to type all this in as one big string. You may get lucky sometimes, but a lot of times no. Okay, finally, another way to write it is like this. So let's fill out, if skipping ahead a little bit, so this, if I put a 2 in, I get 22. If I plug the 3 in, I'd get 24. And I can even read this, crunch of 3 is 24. Again, I say this, the way I read this, I say crunch of 3. Maybe it might look kind of foreign or strange, but all it's really saying is that there's a function rule called crunch. That function does this. It adds 4. It takes a result of that. It multiplies by 2. It takes a result of that. It adds 10. The name of that thing is crunch, and in this case, I'm just dumping a 3 in there. So this does not mean 3 times that. It means I take 3 and dump it into this machine, and it applies these steps. It's basically exactly what we see here. I'm dumping things into the machine and applying steps. In this case, I can read this right off the table. Now, a lot of these, right, most of these I have to compute on my own. but in this case, I don't. I have it up here, so this is going to end up being 24, so that's all it is. Finally, you might be kind of stuck on this. I think my only kind of big warning here is that, so this is kind of what do I do if I dump in any value into Crunch. X is just any value, right? I could use another letter if I want. It's just anything I dump in. How do I say in algebra what this is saying in these words? I think my big caution is to be careful about the order of operations. So, my X is going to come in, so I'm going to add 4. Okay, cool. Then I need to multiply by 2. So in order to show that this is multiplied by 2, I can't, just put the 2 here and say 2 times this, or just put the 2 here and say times this. I need to say times the whole thing. So I got to put it like this. And then I need to add my 10. So that thing is my formula, my algebra way of saying this, following your PEMDAS, right? Then I'm going to do my parentheses first. All right, add 4 first. Then, there are no exponents in this. Multiply by 2, and then add my 10. So I think you should be not really have a problem finishing the other number machine called Munch. And you can see it's really the same kind of notation. The whole setup, function name, arrow notation, and this Munch of 7, that's how you say that. But it's just a fancy way of saying I'm dumping 7 into that machine. What do I get out? Okay, that's it for function notation for our first introduction. Thanks.